The fifth and final section that we're going to deal with in Chapter 4 deals with rational functions. A rational function is something that can be written as a fraction, as a numerator and a denominator. And the ones we're going to be looking at are basically going to be polynomial functions in both the numerator and the denominator. Sometimes one or the other will be just an integer, and they'll take on this form. The function will have a numerator and a denominator, and the numerator will look like this, the denominator will look like that. They'll be basically the same thing, or they could be a little bit different depending on what is there. Just know that these are the a's here are coefficients in the numerator, the b's are the coefficients in the denominator, n is the degree of the numerator, m is the degree of the denominator, and it's just written in standard form here. These two things would be the constants of both. Now, when you're dealing with a rational function, there are going to be some things that these all have in common. They are going to be vertical asymptotes. In this case, I'm going to show you just two of them. And recall that an asymptote is a line that a graph approaches as the values approach infinity or a negative infinity, but never intersect that line. You could also have a horizontal asymptote, and on occasion there might be one that is called a slant asymptote. And this book may even call it an oblique one. Now, the reason I put that in parentheses is because you cannot have a horizontal asymptote and a slant asymptote in the same polynomial rational function. There's either one or the other, or maybe there isn't either one of them, but you can't have both. One other thing that could happen is you may get a place where there is a hole. And a hole would happen at a vertical asymptote. Or where a vertical asymptote is supposed to happen. Sometimes one of these vertical asymptotes may not actually be a vertical asymptote. It may end up being a hole instead. Now, to find these different things, vertical, horizontal, slant, slash, oblique, and holes, you have to understand some things about a rational function. First, the vertical asymptotes. To find them, what you need to do is find the roots or the zeros of the denominator. And of only the denominator. Whatever they happen to be just will be the vertical asymptotes for the most part. It could end up being a whole. And how do you know if it's going to be a whole or not? Well, you have to find the roots of the numerator. So if you have a 0 of the numerator and it's the same as a vertical asymptote, then that is a whole and not an asymptote or a root. And so that you understand when you're trying to find the roots of the numerator, these are actually also the roots of the rational function. Because when you try to solve a rational function, set it equal to 0, to get rid of the denominator, you'd multiply both sides by the denominator, and 0 times the denominator is still going to be 0. So when you set the numerator equal to 0, that's going to find you the roots of the numerator, which are also the roots of the rational function. And if one of those happens to be one of the vertical asymptotes, then that vertical asymptote goes away, and instead there is a whole. And we will go through some examples of this here in a moment once you understand all of the other things that we have to look at. Then, to find the horizontal asymptote, there can only be one. For the horizontal asymptote, you need to look at the degrees of both the numerator and the denominator. Now, when you look at the degrees of the numerator and denominator, one of three things is going to happen. The first thing that could happen is that the degrees are going to be the same. If that is the case, then your horizontal asymptote is going to be y equals the leading coefficient of the numerator over the leading coefficient of the denominator. So that would be if you had something like 3x cubed and stuff after it, and in the denominator it was maybe x cubed, or let's go 2x cubed, and stuff after it. Because the degrees are the same, then our vertical asymptote would be y equals 3/2. So that's the first thing that can happen. Second one. The numerator degree is smaller than the denominator degree. If that is the case, then y equals 0 is a horizontal asymptote. So if you have x to the 4th on top and say 5x to the 5th, then it's 0. Don't worry about anything else, just look at the degrees. That one's smaller, it's 0. And finally, the third thing that can happen, the numerator degree is larger than the denominator degree. If that is the case, there is no horizontal asymptote. Which then, if there is no horizontal asymptote, there might be a slant. Or an oblique asymptote. And the way that you would find that out is if the numerator degree is one more than the denominator. And if that is the case, then to find it, then all you have to do is divide them. And the quotient would be the slant asymptote. If there's a remainder when you do the dividing, don't worry about that. That's not part of anything. All you have to do is worry about the quotient part. So that would be if you had something like, say, 4x to the 5th and stuff after it. And if this was 3x, or no, let's go 8x to the 2nd and stuff after it, then there would be no horizontal asymptote. And because that's more than one bigger, there is no slant either. This one would have to be to the 4th power. And then you would get a slant asymptote. And to find it, you would divide this into that by doing your division thing and putting the 8x to the 4th part on the outside and the 4x to the 5th on the in. Okay, so now we're going to take a look at an example of each of these types. And then we'll go from there. Oh, one other thing I guess we should mention before we move on is the y-intercept. Remember, all you have to do to find the y-intercept is figure out what f of 0 is. And as I mentioned up here, if you want to find the roots, or where it crosses the x-axis, just set the numerator equal to 0 and solve it. So here's our first example. We will start by finding the vertical asymptotes. To find the vertical asymptotes, we set the denominator equal to 0 and solve. Solve this. You can try to factor it, or if you just want to move and take the square root, that's fine as well. So we'll do that, and we'll say x squared equals 25. And then x equals, if you take the square root of 25, that's plus and minus 5. So we know we have vertical asymptotes at a positive 5 and a negative 5. So in our graph, you would have vertical asymptote here and another one here. Second thing that we're going to look at would be a horizontal asymptote. And now we have to look at the degrees. Degree here is 1, here it is 2. Since that one is smaller, our horizontal asymptote is y equals 0. So then we have this horizontal asymptote there. A few other things of interest that you should figure out would be the x-intercepts or intercept. In this case, you just set the numerator equal to 0 and solve it. So x equals -8. So then we know at -8, it is going to cross the axis. Finally, the y-intercept. Substituting a 0 here and a 0 there would be a -8 over 25. And so that is right here. And if you want to know what the graph looks like, when you enter it into your calculator, make sure that you put the entire numerator in parentheses, divided by, and then the same thing with the denominator. And then you can see what the graph looks like. Oh, now I'm guessing, I think it might look something like this, and then possibly this is going here like so, and then this maybe go like that. It's okay that it crosses the horizontal asymptote, because an asymptote, remember, is what it approaches as x approaches infinity and a negative infinity, not necessarily what happens in here. So there's our first example. Example number 2 is this one, 7x over 2x plus 8. We'll go through the same process. Vertical asymptote. Take the denominator, set it equal to 0, and you will get 2x equals -8. And so x equals -4. And so now we know that at a -4, we have a vertical asymptote. Horizontal asymptote, degree is 1, degree is 1, so since they're the same, we use the leading coefficients. So we would have y equals 7/2, or 3.5. And so that would be up here. Figuring out the x-intercepts, take the numerator and set it equal to 0, and x will equal 0. So we know that this is a coordinate. Now then, the y-intercept, if you substitute a 0 in and a 0 in, that's going to be 0 over 8, which is still there. So then, like I said again, if you want to graph this, make sure you put 7x in parentheses, divided by 2x plus 8. And that's in parentheses as well. I would guess that the graph has to do something like this, and then possibly here. So there's example number 2. Here in the third one, vertical asymptote. Set the denominator equal to 0. Solve it, and x equals -5. So then that would mean right here we would have a vertical. Horizontal, this is bigger than that, so there is none. Now, the degree here is 2, the degree there is 1, so here we would have an oblique asymptote or a slant. So we need to find that. And we're going to divide it, and we're going to do it the long way, just because you probably will end up having to do that more so than using synthetic division, because you'll have just a binomial with x in the denominator. And so then minus 50 here. And so now if we're going to divide this out, x goes into 2x squared 2x times. It's 2x squared plus 10x. Do the subtraction, that's 0, negative 10x minus 50. And then x into negative 10x is 2x minus 10, which then would be negative 10x minus 50. And this so happens that the remainder is 0, which is okay. So now our slope is 2x minus 10. So down here 10, and then up 2 and over 1. So approximately right there. And so we would have this as our slant asymptote. And then we probably should extend our vertical one. And understand that it goes down here as well. Now then, the other parts of this we should find would be the y-intercept. And if you substitute a 0 in here and a 0 in there, 0 plus 5 is 5. And in the numerator, it's a negative 50, which means negative 10 would be our y-intercept. So here. Now then, last thing would be our x-intercept. And if we do the numerator equal to 0, we'd get 2x squared minus 50 equals 0. Solving this, you would get 2x squared equals 50. Divide by 2 and it's x squared equals 25. And then take the square root and x would equal plus 5 and minus 5. So that means then here at 5 and at a negative 5, we would have x-intercepts. But because we had a vertical asymptote at a negative 5, and now we also have a root that's supposed to be a negative 5, this place here turns into a hole. Now what that means on your graph is it's going to go through this point. It's going to look like it goes through this. So maybe it does something like, I don't know, this or whatever. Or maybe it comes down. Oh, maybe it does something here. However it looks, on your calculator it will look like it does just this. But understand, at this point, there is no value for it. If you substitute a negative 5 in, you can't do that, because when you put a negative 5 here, and negative 5 plus 5 is 0, and you can't divide by 0. So you will get no answer here. So it's called a hole. And again, if you want to look at how it is on a graph, take your graphing calculator and put 2x squared minus 50 in, put it in parentheses, and then put a divide by, and then x plus 5 in parentheses also. And That's everything you need to understand about this section on rational functions.